Welcome back to Applied Algebra and Trigonometry. We're going to continue solving equations. I'm sorry about the volume problems on the first video in this series. I'm trying to break in a new mic and get things adjusted, and it just wasn't working, so I'm going with the iPad mic right now. Here's a kind of an application problem for you. You might be asked to solve for the current in amps. You have this situation that's been set up for you. Now, where's the variable? The I that you see there does not indicate an imaginary number. Many of you will go on to work in fields where you're dealing with electricity, and when we're talking about electricity, we usually use I to represent current. Therefore, we will not use I to represent an imaginary number when we get to those at the very end of the course. Instead, when you see I, as you do here, it indicates a variable. I've changed the eyes to green, if you can see that, to make them stand out a little bit better. I'm sorry for those of you who are colorblind. I don't know how else to make it stand out. But the first thing we're going to have to do is rescue this poor eye from those parentheses it's trapped in. We need to be able to combine those, so we're going to distribute. As you can see, I wrote little indications that I'm going to distribute that negative 8.85 to the I and to the positive 0.00320. Okay, don't let the decimals throw you. They're just numbers. Work with them. You can do it. You've got a calculator. And using my calculator, I determined that my next step would give me the 0.061 minus, okay, everything stayed the same until I did the distribution. Then I received a negative 8.85i from that distribution and also a negative 0.02832, which I got from multiplying this negative by this positive. Okay, after that, I can combine some things. I have two like terms there. Those numbers are both constants. Plug them in my calculator. I get this number, 0.3268. Not too bad, only 4 digits there to the right of the decimal point. And then when I combine my I terms, they're both negative. So I combine them, I add the numbers and keep the same sign, or plug it into the calculator and get negative 9.38i. Okay, now I'm going to do something a little bit unusual because I prefer to make my variable positive as soon as I can. So instead of moving everything but the variable to the right-hand side, I'm going to move the variable. I'm going to add 9.38i to both sides. And once I've done that, now I've already marked this out because I did this previously, but I have my constant over here on the left, and I have 9.38i on the right. That 9.38 is multiplied by I, so I'm going to divide both sides by 9.38. I am undoing so that I can isolate this variable. And now that will give me, when I plug it into my calculator, this number, 0.348401. But hold on a minute. Do you remember a funny little topic called significant digits? Or maybe you call it significant figures or sig figs? We do have to deal with those, especially in the real world when you're measuring things like current. Okay, this is a current for a radio circuit, by the way. You have to report your answer in significant digits. You also have to report it in one other thing. Take a look at what I originally asked you to do, to report it in amps. So when we get this to the proper number of significant figures, significant digits, we're going to have to put it in amps also. Hopefully you recognize these land masses. We have North and South America there. And what ocean would you say is over here? That would be the Atlantic Ocean, correct? The Atlantic Ocean. And over here on the left would be the Pacific Ocean with a P for Pacific. Well, A and P can also represent other words, such as absent or present as in this number, is the decimal point present or absent? The decimal point here is present. Therefore, we're going to start on the left, just like the Pacific Ocean is to the left of North and South America when we look at it from above. And we are going to start counting at the left. We're going to count this 5 first, and we're going to go all the way to the right until we're done. So since the decimal point is present, we count 1, 2, 3, 4. 4 significant digits. For the number that I've just written, the decimal point is absent. These are commas. Okay, since the decimal point is absent, we are not going to start at the left. We're going to start at the right with our count. Okay, and we're going to just skip all of these zeros. We're going to start counting at the first non-zero number that we reach. So there, the 5 is the first non-zero number going from right to left. So 1, 2, 3. 3 significant digits. And there I have recorded the number of significant digits for each of those. Let's try a few more. All right, here are 2 more numbers. On the left, once again, we have a decimal point that is present. Therefore, we're going to start counting from the left. We're going to begin counting when we reach a non-zero number. So there it is. 1, 2, 3, 4. 4 significant digits. Yes, some of them were zeros, but once we hit our first non-zero number, we keep counting until the end. Okay, from left to right if the decimal point is present, just like the Pacific is on the left side of North and South America. All right, our next number here, 1049, has no decimal point. The decimal point is absent. Nothing there. So we're going to start counting from the right, just like the Atlantic Ocean is on the right. So 1, 2, 3, 4. 4 significant digits. Okay? Yes, there was a 0 in there, but once we start counting from the left or from the right, we count everything. So hopefully that will help you remember. It's not the reason numbers are significant, but it's a good way to remember which ones are. See the videos and other materials to find out more about significant digits. Check out Blackboard. Lots of good stuff there. Now we're back to the problem that we were working on. So let's take a closer look at this. Okay, there we go, closer. All right, is the decimal point present? Yes, it is. It's right there. Okay, that means we're going to start counting from the Pacific Ocean, from the left. So we start at the first non-zero number, 1, 2, 3, 4, 5, 6, right there. Well, wait a minute. That's the answer. How many significant digits are we supposed to have in our answer? Okay, let's look at how many we had in each of the original numbers. In 0.0610, the decimal point is present. Therefore, there are 1, 2, 3 significant digits. Okay, and then we have 1 present decimal point, 1, 2, 3 significant digits in the second. I don't know why I'm putting the dot beside the 3, but oh well. All right, here it's present. 1, 2, 3, still 3. And in our final one, is the decimal point present? Yes, it is. It's right there. And so we start counting at this 3, and we count 1, 2, 3. So each of those have 3 significant digits. All right. If you looked through the materials I've told you to look through, or if you haven't done it yet, please do so. All the materials on significant figures, it will tell you that there are different rules for adding and subtracting significant digits, and there are different rules for multiplying and dividing significant digits. Most of the time, we're going to be doing all of this stuff, okay? We're going to be adding, we're going to be subtracting, we're going to be multiplying. I want you to wait till the very end, and let's just calculate our significant digits then. And usually you'll be doing multiplying and dividing, so use those rules. Therefore, when you're multiplying and dividing, you should have the same number of significant digits in your final answer as you do in the number with the least number of significant digits that you started with. Wow, that sounds confusing. Anyways, in this case, each of those numbers has 3 significant digits. Therefore, your answer should have 3 significant digits. What 3 would those be? Well, let's see. There's a present decimal point right there. So we'll start 1, 2, 3, right there. We will cut this number off here. Because we have a 4 to the right, we will not round up. The number will remain the same. So 0.0348, and remember, we're talking about amps. So for right now, you can just write in amps because we haven't talked about what the symbol for that is. So the current for this problem equals 0.340 amps. Now I would like to show you how your Ti89 can come in really handy, for problems like this. Alright, so here we are with the Ti89 Titanium. And for some of you, when you turn it on, this is the screen that you will see. Okay, this is the app screen. I prefer not to have that as my home page. I like home. You can set that up using your mode button, which is right here. I'm not going to go into that now, but this is where you want to be. So if you're in apps, hit home. All right, and we're going to take a look at what this calculator can do for you in this instance. Okay, for this problem. First, let's add these constants. Remember, this one is negative. Okay, so just typing that in. Let's see, 0 point, and you don't really need that initial 0. That's just there so you can clearly see that I have a decimal point in there somewhere. So 0.0610 minus 0.02832. Okay, and that gives us that value, which is what we had before, if you remember. That was 0.03268. This initial 0 is just there to say, hey, look for the decimal point. Okay. So I've combined my constants. Let's combine the I terms. Now for now, just leave the I out of there. Do the addition of the numbers. Okay, and what you have here is a negative. Now on this calculator, make sure you hit the negative button and not the subtraction button. It does not understand that you mean a negative if you hit the subtraction button. So negative 0.530. Now I can use the subtraction for the minus 8.85. Enter for equals. Okay, now I have those two values there. Now remember, when we did this, what we had was this minus, let me change back to yellow, minus 9.38 I equals 0. Okay, so I added the added 9.38 to the other side. I'm sorry, this is a little shaky right now and not the best writing. I have my iPad upright so I can use the camera. Okay, and now I'm going to divide, as I did before, by 9.38 on both sides. Now that's not too bad. Dividing by 9.38, I could even easily punch that into the calculator if I wanted to. Positive now because I did this, plus 9.38. Okay, but your calculator is really handy because you can also use these arrows. And if you go up, I want to take that number that I've just highlighted and divide it by 9.38. So now that I have it highlighted, I'll just hit enter and it appears down in my working area. Okay, and now I'm going to divide by my other number. Okay, and I hit enter, but wait a minute, that has a negative in it. So I can scroll over to that negative. Can you see that? I scrolled over to the negative, and then I'm going to delete it. Okay, and now I have the division that I want. So on this side, it's just going to cancel. I can just hit enter. So boom, and there's my answer, okay? Not this. That's set it up so it's ready to go again. Here's my answer. And it goes out even further because I've adjusted my calculator to give me lots more decimal numbers than I need. Because remember, this started with 3 significant digits in each case. So I have I equals 0.00348440. I will often write out a number like this and just kind of trail it off to show you what you should have in your calculator. And then, where are my 3 significant digits? There they are, 3, 4, 8. Remember, I'm not rounding up. Okay, and it was in amps. Calculator won't do that for you. You have to remember the units yourself. So we have spent our entire time together looking at this problem. Okay, we've looked at it. We've used this to talk about various things such as significant digits and the use of your calculator, but most importantly, that you should not get stressed out when you see numbers like this that you're maybe not used to working with. You'll get used to them. The same rules apply. Take a deep breath. Take it step by step. I'll see you in class.